Behzad Fatahi is an Associate Professor of Geotechnical and Earthquake Engineering at the University of Technology in Sydney. He joins us now from there. Thanks so much for joining us on TRT World. Behzad, in the aftermath of these devastating quakes, we're seeing buildings right next to each other. We've seen a lot of aerial shots of cities that once were. And some of these buildings have been leveled completely. They're just a pile of dust, and yet ones standing next to them seem to be perfectly fine. What causes some buildings to collapse? Is it based on age, other factors, or a combination of several things?
Yes, thank you. Yes, obviously this is based on the combination of different factors. And if you consider we design and construct buildings, bridges, roads, pipelines, and so on, that they can stand earthquakes with return periods of 2,500 years. So what happens is that the designers and builders, they must comply with the building code. And there is a particular code which is called seismic code, that they must basically comply with this seismic code. So I understand Turkey has got a seismic code which is basically last updated in 2018, and previously before that was updated in 1999 with a major basically revisions such as consideration of seismic design criteria, soil classification, new building materials, and so on. And in particular in that code, which was updated in 1999, they had a provision for retrofitting the buildings. So what happens is that there are many buildings that they might be old and they were not designed to that code of 1999, or I say some of them even to 2018. Means if there is a building there which is 25, 30 years old, doesn't comply, may not comply basically with those codes. And that's why they may not basically resist those basically large earthquakes, similar to what unfortunately we are seeing sadly here in Turkey.
And Behzad, I understand that you and your team at the university in Sydney developed a few years ago a type of material that is good in terms of trying to reinforce buildings to withstand earthquakes. Could you talk to us a bit about what that material is and how often or widely it's used in buildings in either Australia or other parts of the world?
Sure. Our team at University of Technology Sydney, actually we developed and tested a new foundation material using geosynthetic materials in a way that we change the properties of the foundation in a way that when earthquake comes to the ground and then tries to propagate to the building, this geosynthetic material basically allows the foundation to rotate more and absorb the energy and doesn't let more energy to transfer to the building. This is one of those solutions that we develop, which is quite cost effective and relative to other solutions such as base isolation and so on. But these solutions, they must be adopted basically into the building codes, and then designers and practitioners, they must adopt them. And we have also developed other techniques that definitely they could help. For example, for bridges, we have developed some anchoring system. For buildings, we have developed a post-tensioned cables that they can connect the building to the foundation, and it just changes the flexibility of the building. In fact, one of the key techniques to protect the buildings against larger earthquakes is changing the flexibility of the entire building and foundation. You imagine if you have got a very rigid building anchored into the foundation, when the shaking comes, the entire shaking transfers to the building and of course damages the building. If we can make it a bit more flexible in a way that it damps the energy and doesn't let this energy to destruct the building, that would be basically a protective system that we have developed.
So Behzad, I'd like to understand for the survivors of this earthquake, there are still many buildings that are standing. Most survivors are living in shelter provided by disaster management agencies. But the buildings that are still up, how will they be assessed as to when they're actually safe to return to and for people and families to start living there again?
Assessment of basically buildings post-earthquake, that is it livable or not, is just quite lengthy process. Basically, a team of experts, they must visit these buildings while they are closed to look at the severity of the damage, what are the cracks, where are the locations of these cracks, are they these cracks, have they jeopardized basically the integrity of the building, is the problem in the foundation, or is it inside the structural members? For example, if the problem has been in the foundation, let's say you have a soft soil or liquefaction happening to the building that the entire building tilted, unfortunately, fixing this problem won't be very easy. If the problem has been, let's say, in cracking in the facade of the building or some of the structural members, then some of the mechanisms and techniques of retrofitting can be done. But this is a very time-consuming, basically, process. But and I think it can take months, actually.
Behzad Fatahi, really appreciate you speaking to us and for your expertise on this matter.
No worries.